Here we're told about an object that's projected horizontally in the x direction at a given speed from the top of a tower with a given height. So imagine the object is there and it's being projected horizontally. So what we know is the velocity, the initial velocity in the x direction. And it's asking three things. It's asking for how long does it take to fall to the ground. So it's asking for the time. All right, so how long is time? It's asking how far does it travel horizontally. So they're asking for this distance, x, or perhaps we should call it sx, the displacement in the x direction. And they're asking for the speed just before it hits the ground. So we need to find the magnitude of the velocity when it hits the ground. So the best way to deal with projectile questions like this is to split two sets of parameters. Parameters for your horizontal movement, in which there is no acceleration because there's no net force, and parameters for your vertical descent, free fall, which is accelerating at a rate of minus 9.81 meters per second squared. Now, you don't have to have a minus sign there. I include a negative sign because it's negative descent. So the direction of the acceleration is downwards, so that's the reason for the minus sign. Now, what else do we know? We know that for the entire journey, the vertical displacement will be negative 35 because it's falling by 35 meters. So it's negative 35 meters displacement. So the displacement is a vector from where the object started to where the object ended. So vertically, it's 35 meters in the negative direction. If you don't put that negative there, then you can't put that negative there. So my convention is upwards, positive, downwards, negative. So I've got negative displacement and negative acceleration. Now, the velocity we're given is horizontal. So that will be my horizontal velocity. And because there's no acceleration, then u and v are the same. So it's 15 for u and 15 for v. Vertically, initially, there is no velocity. It's not moving initially because it's moving horizontally. So in the vertical direction, there is no initial velocity. V is unknown. We're going to need that for our third part. T is unknown. T here is unknown, and S is unknown. So basically, we need to find S, V, and T. So let's start with how long. It's pointless working in the horizontal direction because we have absolutely no information. All we have is velocity, and that's useless. But here we have 1, 2, 3 pieces of information, so we can find T. So we need the equation of motion that links S, U, A, T. So I will say S equals ut plus half at squared. So my 35 is equal to 0 plus half times minus 9.81 t squared. So you can say t is the square root of 35 times 2 over 9.81. And that will give you 2.67 seconds. Okay, so that is the time to fall to the ground. So that's my initial answer there. That's 2.67. That's the first thing that we found. Now it's asking to find how far it travels horizontally. They're asking for the distance, sx. Now, because horizontally there is no acceleration, there's just constant speed, because it's subject to Newton's first law, then the only equation we can use is displacement equals velocity times time. That's the only equation that we can use horizontally. So we can say S equals ut, and therefore Sx equals 15 times, and we can use the same time because it's the time spent traveling horizontally is the same as the time spent traveling vertically. So let me just make it clear that this time is the same as that time. So if you multiply those, you get 40.1. So that's the answer to part B. How far does it travel horizontally? It travels 40.1 meters. And finally, it's asking for the speed just before it hits the ground. So they're asking for the speed at this point. So we know the horizontal component of the speed. We don't know the vertical component of the speed. So remember, as it hits the ground, if you imagine this is the ground, as the object hits the ground, it's going to have two components of velocity. It's going to have a vertical component and a horizontal component. The horizontal component is constant at 15, that doesn't change. The vertical component we need to find. And once we find these two components, we can then find the speed as the resultant of those two components. So let's find Vy. And to find Vy, we need to operate in the vertical direction. So you can use any of the equations of motion. I'm going to use the one that doesn't involve the time, just in case we made a mistake here. So I'm going to say v squared equals u squared plus 2as. So that means v is the square root of 0 plus 2 times minus 9.81 times s, which is negative 35. Now, if you don't put the minus sign, you'll end up with a negative square root, and that is impossible to calculate. So you either have a minus here and a minus here, or you have a plus and a plus. You can't have just one negative sign. So my velocity will be 26.2 meters per second. So that's my Vy. So I can put that there. And now what they want is the magnitude of the velocity, which is the speed. So I'll write that out. So speed is the magnitude of the velocity vector and that's going to be the square root of the horizontal component squared plus the vertical component squared. And that'll give you 30.2 meters per second. And that's the answer to part C. So whenever you encounter a projectile question, try to split your work into work in the x direction and work in the y direction, because horizontally there's no acceleration. Vertically it is accelerating, and because it's accelerating in the downward direction we use a negative sign. If you don't choose to use a negative sign, if you think of it as accelerating in the positive sense, getting faster, you can use a positive sign there, but then you would need your displacement to be positive too. Okay, so that's how you would answer a question like that. I hope you found it helpful.